Hello everyone, today we are going to be discussing the average value theorem, and then we will also be talking about how to find the total volume of a solid with a known cross section. So I'll just write our objectives down real quick. Okay, so okay, so that's number one. Another one, the volume. Okay, so here we go. As you can see, we're first going to start off with average value theorem, and then we will start talking about volume with known cross sections. So I hope you were able to learn something from this, gain something new. We'll start off with just a quick explanation about what average value theorem is, also known as AVP. Okay, so the average value theorem, also known as the mean value theorem for integrals, you might also hear that. It says that if f of x, the function, is continuous, now that's very critical. Make sure your function is always continuous, or else this theorem is invalid for your example. If it's continuous on some interval from A to B, closed interval, then there exists some sort of value in the interval. Now you see on the interval such that f of c, so the value at that point equals to 1 over b minus a times the integral from a to b of your function f of x. Okay, so this is, like I said, the mean value theorem for integrals. We commonly call it the average value theorem. So basically what it is you're finding f of c, which is basically your average value. What this is if you have a graph and your function is your function f of x and closed interval, which is from a to b. Basically what this is you're finding your average height. So this would be your f of c value, if you use that theorem. So just think of this as you're finding the average height of your function
and that might be able to help you out kind of understand what that is. And you can, it might also ask sometime for you to find the average velocity, which is basically the same thing, except to find the average velocity it would just be something like with respect to time. So 1 over t2 minus t1 could be any sort of time interval that gives you integral from t1 to t2, and then your velocity function with respect to time. So those are just common examples that you might see or come across on. So you could have, like I said, f of x, just some sort of regular function. And you could also have a velocity function.
Okay, so let's do some examples.
Okay. For our first example, we're going to start off a little easy. It's just going to be f of x equals cosine x on the interval from 0 to pi over 6. Okay, so we want to find what is the average value of cosine x on the interval from 0 to pi over 6. So how we set this up, we're going to use our the theorem that we just talked about, the average value theorem, would be 1 over b minus a. B is pi over 6, and a is 0. 1 over pi over 6 minus 0. The integral from a to b, which is 0 to pi over 6, times your function, which is cosine x. Okay. Now, basically, after you get to this point, really, really simple. You're just solving an integral, so you have 1 over pi over 6 in the front, and then we find the integral of cosine, you get sine x. And then you have your limits from 0 to pi over 6. Okay, now you can just solve for this. So what you get is 1 over pi over 6 times plugging in your values, sine of pi over 6 minus sine of 0. So these very nice. These are actually really easy values to find. We've got 1 over pi over 6. Sine of pi over 6 is 1/2, and then sine of 0 is just 0. So really, you just multiply by 1/2, and then your final answer is, we flip that, 6 over pi times 1/2. And the final answer is just 3 over pi. If you multiply 6 times 1 equals 6, pi times 2 is 2 pi. If you simplify that, you get 3 over pi. So the average value from cosine x from 0 to pi over 6 is 3 over pi.
Okay, so let's do a little more complex example. Okay, so what we have here is f of x equals x squared times the square root of x cubed plus 1. And your interval is from 0 to 2. Okay, so your first instinct might say, how do you tackle that? That looks pretty nasty. Well, what we're actually going to do is do substitution. So we are going to combine other calculus methods that we've learned to solve for the average value. So our u is going to be
Chat Personius and Isaac Davis to the office, please. Chat Personius and Isaac Davis.
X squared. And so you got 3x squared and then the x squared in front for f of x. So really, not that dx. Okay. So you can divide it by the 3 on both sides. So you have 1/3 du equals x squared dx. So as you can see, the x squared matches what is in front of our f of x. So that takes care of that. So now we can set up our integral. What
you help. First, actually, we'll just change our limits real quick. So plugging u of 0, you get 0 cubed plus 1 equals 1. And then you get 2 equals 2 cubed plus 1 equals 9. So those are going to be our new limit values. Okay, so now let's set up our integral. Okay, perfect. So what you have here is, remember, just use your formula, 1 over a minus b, or b minus a. So you have 1 over 2 minus 0. And then we're going to take that 1/3 out. Because in the beginning we divided both sides by 1/3, so you have to remember to take that out. And your integral from 0, oops, like that. We change our limit values, so it's actually from 1 to 9, and then we use the 1/2, because our original function was x squared, which we took care of by finding du, which was x squared with 1/3 in half in the front, and then times by square root of x cubed plus 1. So really, since that's u, it's into the 1/2. Du. So now we're just going to solve the integral. So you get 1 over 6 in the front times 2/3. If we solve the integral for u to 1/2, is 2/3 u to 3/2 from 1 to 9. Okay. Now let's just do some algebra. Got 1 over 6 times by 2/3 times 3/2 minus 2/3. Because if you just plug in 1, you get 1 to the 3/2, which is basically 1. And then you have the 2/3 in front. Okay, so let's simplify this. So 1 over 6 times by, let's see here, I have it written down. So basically, 9 to the 3/2 is actually just 27.
Any student that has not checked out yet, please make your way to the cafeteria at this time to check out. Any student that has not checked out, please make your way at this time.
4 over 3 minus 2/3. And then we'll get into our final answer, which is 1 over 6 times 2 over 3. Final answer.
Gail or Janelle, please call extension 4100.
That is 26 over 9. Okay, so there was a little more complex example. Like it showed you, you can use substitution. Use substitution to also find the average value of a function. Okay, so now we're all done with ABC. So now we are going to do that. We'll talk about volume. So how you find the volume using it in a rule. Write down another theorem here. Sectional. Okay, what this says, that A of y, this is your area function with respect to y. The area. Horizontal cross section. This is the cross section of your solid. solid. From two different points. So we're going to y big by e. Okay. So then we know that the volume of this solid equal to the integral from a to b times your area function respect to y. But you can also, this is the same thing if you want to go respect to x, you can also do that. It would just be the integral from a to b times a to the x dy. Okay, so let's kind of explain what's going on here, and then we'll do some examples. So basically, say that if you have a solid that, let's just say you have some sort of foam that's sticking out, sticking out of the ground or something. And then if you took a cross section of this, say that the cross section was a semicircle or something, just some sort of shape. What you can basically think of this as, if you have a semicircle, you can use the area of the semicircle, find area function, which is area equals 1/2 times pi r squared. You can use that function, if this was like an xy coordinate plane, to find the total volume. And so what you do is, this is your diameter of your semicircle, sorry. And then what you can do is just use this. We're going to use r as the value in our function. And so what it would be is basically just like the top function minus the bottom function. This is kind of a weird drawing, but it might make more sense in this example that I did to you. What's that? So we'll just start off with an example and see. Okay. So what you have here, say, given this problem, okay, that's not really a good drawing, but so this is R, this area here is R, and this is 9, 6. So you have the horizontal line y equals 6, and then your function here is the line y equals 2 into square root x. And the problem is,
Cardinals, this is your last
for each value,
page. If you have not
y,
checked out at this point in time,
when
you need to come down right now and get checked out. Any student that has not checked out, get down here now.
cross section of this solid is perpendicular to the y-axis is a rectangle height, or just the width, height, 3 times the length of the base region in R. Base in here's the problem. Now, how we're going to tackle this is say this, so what it's talking about is this value, or this area, R, is the base of a solid. So each shape, you can just imagine that little tiny rectangles are extending from off the top of this. Little rectangles, oh, sorry, that's not very good drawing. So you just imagine that you have a bunch of rectangles that are kind of extending from this solid. Okay, so now what you can do is, if you know the area of a rectangle, how do you do that? We know is length times the height.
If there are any upward bound students in the building at this
So
time,
this is the
please go see
function
Miss
that we're going to use.
Chrisanne.
We need to find a of y. So we're going
And that is the end of the day.
your length times your height. This is basically what we're looking at. So what we need to do is we need to find the length function and your height function. Now it gave us in the problem what the length is. We're going to go back to our function. Our function is y equals 2 of x. So what we need to do is get that in terms of
Obed Muniton, if you're in the building, please report to Mr. Valdez's room. Obed Muniton.
so what that is you got y over 2 equals x, which means that x equals y squared over 4. So this is the length of your rectangle. So we found the length, and the length is y, which is x equals y squared over 4. Now we just need to find the height. Well, it said in the problem that the height is 3 times the length of its base. So that's pretty easy because we already found what the length was. So you know that your height is going to be 3 times your length, which is y squared over 4, equals 3y squared over 4. Beautiful. Okay. So now let's set up our integral. So your volume equals the integral from 0 to 6, because in our picture you can see down here you have from 0 up to 6, so there's our limits, that's how far we're going. 0 to 6. Okay, and then times your length, which is y squared over 4, and your height is 3y squared over 4. Okay. Now let's simplify that down to be more pretty. So you got 3y to the 4th over 16 y. Okay, now you just solve for your integral, which you get 3 over 80 y to the 5th. 0 to 6. And then you plug in your values. This is pretty easy. You know that when you plug in 0, it's just going to equal 0. So we can go 0 to 80 times 6 to the 5th. Which is a pretty big, nasty number. So we're actually not going to simplify it because generally, at least in calculus, you don't have to simplify it if you're not asked to. So basically, that's how you find the volume of a solid with no cross section. So basically, all you're doing is you're trying to find the area, as long as you know the area of the shape that it gives you. If you just find the area of the base, use that and plug it into the integral, and it will spit out the volume for you. I hope you all learned something.